All right, hey guys. Hope you are enjoying your day off. I'm gonna go through two problems today because I'm not gonna be here tomorrow as well. So what we're doing is we're taking a look at the systems of equations we've learned and applying them to different types of problems. So I have the assignments are gonna say Fathom, but I'm just using GeoGebra because I don't have Fathom at home. So if you hear any noises, because my boys are running around crazy, so hopefully it won't be too distracting if you hear them. All right, so we're going to start off with just doing a few questions today. First one, suppose X represents the number of people who attended the Dapper Dan basketball game in Pittsburgh, PA. We're going to let C of X equal 5X plus 40,000 represent the cost of hosting the game. So C of X is the function that represents what the cost is to host. So for there's like the upfront cost of $40,000 maybe to rent the basketball facility, $5 maybe for every person that comes. You're going to pay $5 for like janitorial services. So the formula for just the cost to put on the basketball game is 5x plus 40,000. R of X equals 30. That's going to be your revenue. That's going to represent the total taken in from the game. So that would be like $30 a ticket. So the people putting on the game are going to make $30 per ticket. So we want to graph these two functions, which I have graphed here. And we look to see, as we know, that the intersection point is our solution. So if you look at letter B on your notes, it says for what attendance is revenue equal to the operating cost. So where my two lines intersect, that is the break-even point right there. All right. So we know that when X is 1600, that is our break-even point. So we come back over here and we would put solutions 1600 in solution set. Now don't know how this is going to be. I'm using my cursor, my finger to write this. So 1600, and then we'd write a sentence answer saying the attendance of 1600 people would allow them to break even. All right. So then letter C. For what attendance is revenue greater than the operating cost? So we come back here. So it's where revenue is greater than the operating cost. So my revenue equation is this green line because remember we started at, my revenue equation is the blue line because that's just the $30,000. The $30 per ticket. And my green line here is the operating cost, the 5x plus 40,000. So the question's asking for what attendance is revenue greater. All right. So again, this revenue line is the blue one. So when is it greater than this other line is everything after 1600. So when more than 1600 people have come to the basketball game, according to our line here, it shows that you will be making more money. Because remember X, which I don't think you can see down here. Let's see. There you go. Now you can see it. Okay. So this is at 1600 right here. So everything up here is greater. So Y again is how many people attend. No, I'm sorry. This is how much money it cost. X value right here is how many people attend. So at this point, this is when you start making a profit because you have spent. This is what it cost you. This is what you make. All right. So we go back here for what attendance is revenue greater than the operating cost. It's when X is greater than 1600. So for everything after 1600 is when you are starting to make money. There we go. All right, so then we write a sentence answer saying, when the attendance is greater than 1,600 people, the revenue is greater than the operating cost. All right, so what is the attendance when the revenue is less than the operating cost, and how does this relate to profit? Okay, so we go back. Again, my blue line is the revenue cost. So everything from 0 people to 1,600 people, you have not made any money by putting on this basketball game. So for all these values, you are still in debt. Now again, graphically, how do you tell this? It's because you look to see which line is above the other, right? So on the last question, my blue line, the revenue, was above the operating cost after $1,600. So everything here, this is the money you are making. This is the money that is costing you to put on the basketball game for every amount of people that attend, right? So the more people attend, obviously the greater difference right here is, and this is your profit. So your profit is shrinking when you have just above 1,600 people. You still have a profit here, but you don't have that much profit. So the break-even point is at 1,600 people. But what happens when less than 600 people come? You are losing money, because this is the amount of money it's going to cost you to put this basketball game on. Even if 0 people come, you remember your y-intercept here is 40,000. So even if 0 people come, you're still paying $40,000 to put the basketball game on. So if you go back to this problem right here, for what is the attendance when the revenue is less than operating costs? Well, that's when your X is less than 1,600 people. And when that happens, you don't have a profit. So then the second part of this is, and how does this relate to the profit? The attendance is less than $1,600 shows the revenue is less than the operating cost. So they will lose money. All right. And then the last part of this problem says, write an equation or inequality that relates to each question above. Okay, so what we did here is we first found our solutions, but then when the questions asked us to write an equation or inequality, okay? So my equation here is, when are my two graphs equal? So we just write an equation stating when the two graphs are equal. So 5x plus 40,000 is going to equal 30x. So that is when my equations are equal to one another. Why? Because again, it's when the attendance and the revenue is equal to each other. All right. So then letter C, for what attendance is revenue greater? All right. So when the revenue is greater, we want my revenue equation to be greater than my operating cost equation. So this is actually becoming an inequality. So what is the attendance when the revenue is less than the operating cost? Well, that is when X is less than $1,600. And that occurs when my blue line right here is greater than my green line. So when my revenue line, this 30X line, is greater than the 5X plus 40,000. So that's exactly what I write here. It's when 30X is greater than the 5x plus 40,000. And again, it's just look to see, when is it above? When is it above? Okay. And then this last one, what is the attendance when the revenue is less than the operating cost, and how does this relate to the profit? So again, this is when my now 5x plus 40,000 line is greater, it's above my 30x line. So now I would say, write the inequality like this. All right, so this was question 5. We will move on to question 6 on the next video.